Hi, we are Team 22 and in this video we discuss about how we design and implement our own new programming language which we have named as APT. The name APT is derived from the initials of our team member's name, and also we found it catchy as we can relate it to an acronym APT for aptitude. The inspiration for our new language was C language. The parsing logic is implemented using Java and Antler 4.5. Runtime is written in Java. In our language, integer and boolean are the data types which are supported. Also, support for scoping is provided using local and global variable definition. We have used if then else as the conditional statements. For loop is used for looping. The data structure used is array. We have also support for functions, recursion and print statement. The high-level language programs corresponding to our new language has extension .apt. For example, add.apt. When we compile add.apt, intermediate code will be generated in a file named add.intr. In our language, we have tried to keep variable definition and initialization simple and short. User can define a variable like integer a. Similarly, he can initialize a variable like a equal to 12.
Hi, let me show you the grammar of APT language. The grammar will start from a block and it will actually look for the end of file. The block will have function declaration and statement. In statement, we are supporting assignment, function call, if statement, for statement, variable declaration, and return expression. Let me show you the whole grammar of APT. This is the grammar file which we are using in our language. As I mentioned earlier, this particular grammar will support for if, for statement, global and local variable scoping, recursion, and function declaration. We have support for addition operator, subtraction operator, division operator, multiplication operator, and equal operator, greater than and less than operator also. We have support for print statement, we have support for if, else, and for loop. Let me show you the parser which we have written in Java using Antler. So this parser will take high-level language as input. It will generate the parse tree. Using the base listener class, base listener file, it will actually generate the intermediate language. Let me show you the full code of APT base listener file. Now let's try starting. Now let's try executing a particular code. So the input will be a high-level language which I will give input to my apt.jar and it will produce a .intermediate language. So when I run this particular code, it will generate the parse tree and the intermediate language. Let me show you how the parse tree is generated. So as I mentioned earlier, in our language, the starting point is block. So I am actually doing the addition of 3 variables here. Let me show you the code of. This is the high-level language code for the arithmetic operation. Here I have defined 3 variables, integer a, integer b, integer c. After that I have declared the value for those 3 variables. A is assigned with 12, b is assigned with 10, c is assigned with 20. And then later I am printing the sum of all the 3 variables, multiplication of all the 3 variables, the variable c subtraction with a, variable c division by a. So let me show you how the parse tree looks like. So in the parse tree, first there is a variable declaration for a, b and c. There is an assignment for a, b and c. Then there is a print function call. Inside that there is an expression operation which does the sum for a and b, store it in a temp and store the value and then do the sum with the third variable. Same here also, it does the multiplication for a and b first, store the value in a temp variable, then do the multiplication with c, and this is for subtraction. Let me show you how the intermediate code generated looks like. This is how the arithmetic for the arithmetic.apt. This is the arithmetic.intermediate code. So every variable defined will be a global variable if it is defined outside a function in our programming language. So A, B, C variables are defined with global int. They are loaded with the value 12 for a variable A. Variable B is loaded with value 10. Variable C is loaded with value 20. For the add operation, we have A and B. A and B will be added and kept inside a temp variable. Temp variable will be added with the third variable, that result will be stored in a temp2 variable. And the print statement will actually access that particular temp2 variable and print it. Same goes with multiplication, subtraction, and division. Let's do the parse tree generation for a recursion program. I will execute a recursion of a factorial code. This is the parse tree which has been generated. Let me show you the factorial recursion program. Here, first we are defining a variable, then we are assigning that variable with a value, then we are calling the factorial function. The factorial function is defined here. Let me walk you through the parse tree for the same particular factorial code. As I mentioned earlier, the program will start from block var declare. Here we are defining a variable int n. We are assigning the value n to 5. We are actually then we have a function call. The function is calling the fact function here, and this is the function declaration. Let me show you the intermediate code generated for this particular file. First we define the integer variable, then we load the value inside the n, then we push n because there is a function call here, fact. Now this is the function definition. Then when we call the function, we actually pop the variable n, check if it is equal to 1. If it is equal to 1, then we will return 1. Otherwise, we'll call function, we'll call this particular line of code n into fact n minus 1, which is explained here. First, we'll do n minus 1, store the value in temp1, then we push that temp1 inside this function fact. We'll do the multiplication option, call this function and put the value in temp2, and then return of temp2, and this is how we end the function.
Now let us look into the runtime code. This code is responsible for taking the input. That is, the input for this file is the intermediate code which is generated. So the main functionality is the intermediate. The following intermediate code is broken into tokens, and since the left hand side is always the function that needs to be performed, in our code we have used it as switch cases, so that if you want to perform a load operation, it comes to the load, and that variable, that is the next token, will be pushed to the map. So here we are using symbol table and a boolean map, that is using hash map, and we have implemented stack using array for performing push and pop operation, which will be required when we perform recursive functions. So now let us look at an example of recursive function. Now in this recursive function, we give the input value as 5. So when we run the program, we get 120 as the output, And now let us look into the if case. In the if case, we are declaring two variables, and here we are checking whether a is greater than b, and if it is greater we are printing a, else we are printing the value of b. And now we have got the value 10. And now let's look into local and global variable. Here, to differentiate the blocking, we have just added a variable inside a function. So now sorry. So now inside the function, when you are printing a, the value 8 should be displayed, and after that the value 7. So now let us look into the output. We are getting the output as 8 and 7. And now let us look into the boolean. Here, if c, the value of c is greater than d, we print true, else we print false. Now since the value of c is less than d, we get the value false. That's it. Thank you.